We're now going to do the second part of the video of making the Meriam Abbot crankcase. And obviously I haven't soldered it together yet, I'll show you that. But first we have to make up the two bosses that go on the end that mount the bearing housings. And there's one large one and one small one. So we'll make those first because those have to be soldered on also. What we're going to do is I'm going to make the small boss, and I've got this jig that I've made up to hold the part. And we'll just put that in the 3-jaw and turn it. I've already cut the edges off of it and got it somewhat round. Put this in the 3-jaw chuck and tighten it up. I've got to get a wrench here so I can tighten it good. It's going to be the small boss, and it's 630 OD. So we're going to turn that first on the outside, and then we'll do the inside. Hey, almost there. That's rough to the outside. I'm going to take this off of here, deburr it in the sander, and then we'll put this in the 3-jaw and bore the inside. So as luck would have it, this fits perfectly in between the little grooves here, so I don't have to do any special setup on this. And I can bore that hole in there. So this is just a rough cut, so I'm just going to drill that. It says 3/4 of an inch, so we're going to be boring it in the milling machine later. So I'm just going to drill that out. So I'm going to deburr this, and eventually it'll get soldered on to the side here. And the finished size on that hole is 7/8, so I've got an 1/8 inch to fool with here. And that's just going to get soldered right onto there, dead center. Now we'll do the big one. So I'm going to rough saw the corners off here just to save myself a little tooling. So now we're going to go back to the handy jig again and turn the outside of the large boss. Okay, I'll just double check that measurement. Okay, that's about 15 over. I'm going to take that off. That should be just about it. Yeah, perfect. So the plan says to make this 1" 6/30, and the finished dimension is about 100 thousandths larger than that. So I'm going to drill it out and bore it out to that dimension. That has to go out to 1" 6/30, so I'm going to have to bore it the rest of the way. The largest drill bit I got is that 1" one. 300 thousandths to go. There it is, 630, 1 inch 630 is right there. So 156 on, what the hell's holding that? Huh. See, that's the center of the hole there, so we've got that. Next thing we got to do is we got to center this on here and put a couple of screws in it to hold it, to solder it. So what I'm going to do is make a little jig that fits in there, goes through this hole, and I can put that on there, and then I can drill and tap my holes to hold it on, and I'll do the same for this side here. What I'm going to do is take this piece of scrap aluminum that I had around, and I'm going to drill and ream a 5/16 hole in that, and turn the outside so it just fits inside that ring, and that will center it. So the hole wasn't quite concentric, so I ran a boring bar to get it perfect. That's probably within one. We'll just take one off. There it is. That's it. So there it is. What I did is put a dowel pin in here. If I put that in there, that will center that absolutely perfectly. And what I'm going to do now is put a couple of screws in there, and that'll hold it in place to solder it. So I checked the plan, and there's the piece that bolts on here. I don't want to put the screws where that screws in too, because they'd be interfering with each other, or they'd be half in and half out. So if I put the screw top and bottom, then the other screws are across this way and there, and they won't interfere. So, and that's the same on this side too. So what I've got to do is come on the center here and just put 2 screws. One there. So I got that one drilled, and I'm going to stick another drill in there to hold it in place while I drill the second one, so they'll both be aligned. It has to go on this way, and I don't want to forget how it goes, so I'm going to flip it over. I'm going to put a prick punch mark right next to that hole, and then I'm going to put a prick punch mark right here, so I always know which way it goes on. Then I'm going to take this one and drill a clearance hole in it for a 256. These countersinks have to go in flush because there's a bearing housing that goes on here, and I'll just leave the screws in there and they'll stay there. There's that one, and now I'll turn it over. We'll do the other one on this side. So this one should be a little bit simpler. All I'm going to do is face this off, and it's almost exactly the size of that piece of aluminum, so I'm just going to have to bore a hole in it and just touch the outside, and it'll fit right on there. So this almost fits on. That's 3/4 and this is 3/4, so they're just going to touch it with a file till it slides on there. Might be just some burrs on it. Okay, that's it. Nice fit. So here again, I've made a jig to hold it exactly where it belongs, and I've drawn a line across there in the middle, and I'm going to put the screws up and down. It doesn't even matter, just as long as they don't get in the way of the other screws, because they don't show, and they're just there to hold it while I solder. So I'm going to put them out near the edge here. Two of them. So here again, I'm drilling the tap hole all the way through. Okay, So there's the two bosses installed with the screws, and the next process will be to take this apart, and I'm going to first solder the top and the bottom, and then I'll solder one side on, and then I'll do these two side plates, and then I'll do the top plate, and then it'll be finished. The first thing that we have to do is take this apart so I can do it. And I have changed my mind. I think I'm going to solder these two bosses, or the bearing buildup, on first, because I only have to heat this piece. If I wait till I put it together, I'll be trying to heat the whole thing. So I'm going to take it apart now, and we'll do that first. That's it. Okay. So we're going to start with this one. I'll take the boss off and clean it up, and we'll solder it back in place. Now, as you see, I've put the liquid solder on there. This is Stay Clean, and I always put a little bit of the no corrode on the inside. It seems to make it flow a little better, and it doesn't seem to interfere with anything, so I do that to help it out a little. And then we'll heat it up and solder it. So I'm going to start off by putting on the Stay Clean liquid flux around the circle. And I've got a match mark on here. I got to line that up, drop it in place. A little bit of the no corrode on the inside here, and it'll work its way through. It seems that the two of them work really good together. I don't know why, but sometimes when I just use the other flux, it doesn't go in as good. cleaned these pieces up, and the next thing is I'm going to put the top and the bottom on. But I'm going to put the jig back in there because this will hold it perfectly square as I solder it. And that's an important thing, to have it perfectly square. I'm going to square this back up with the jig, and that way we'll know it's perfect. Tap that down. Mallet. Now that should be reasonably square. What I'm going to do is take this over to the surface plate and check it out. Seems perfectly square. Yep. Here again, I'm going to put the no corrode flux on the inside here, and I'm going to solder it from the inside and draw it to the outside. The solder will move towards the heat, so I'll heat the outside finally and touch the solder on the inside, and it'll draw it out. So we get this on the inside. I like lots of flux. Make sure I do a good job. Okay, did I get it all? I guess so. I'll do the top first. I guess you can see in the video, it drew it right to the outside there, and it's well soldered. Now I'm going to flip it over and do the bottom while it's still hot. Now if you get too much solder on there, what I do is I put a little flux on the flux brush, and you can brush it off and clean it up. It's the easiest way to do it while it's still hot. And you get, that also brings out the solder joint, if you can see it now, that it came right through. Now that it's cooled down, I can take that jig out of there, and that's probably the last time I have to use that. Now we'll clean up to do one side. Doesn't matter which side I do first, but I want a good joint on that top. Hit that with a piece of paper. Is odd. As you can see, that these screws are quite difficult to put back in because they're so small. For some reason this last screw doesn't quite want to line up and I can't put it in, so I'm going to put a clamp on that and pull it over just a little bit, and then hopefully I can put that screw in there. It all lined up when I had it assembled at first. As luck would have it, that last screw didn't quite line up. So what I'm going to do is I'm going to run a tap down in that hole, because it's just a tiny bit off and I can't put it in. And look at that, the tap goes right in there. There it is, the last screw. There it is, a nice tight joint. I think I can solder that real well. Up in here, I've got a little tiny bit of solder so that the side plate won't fit. So I'm gonna just take a file and take that solder out of there, hopefully. Not much, but there. You can see it shined up right there. Mostly right there, that's good. I think that one will go in there now if I started in with a tap. Clean the hole out. There it is, that's the last screw. So this one, I'm going to solder the outside of the top, and then I'm going to flip it over and try to solder it from the inside through this hole here and that hole. So first we got to start here and heat that up and solder it. Turn it one more time, trying to finish it through the top. So we set this up to bore the top and the bottom at the same time. What I'm going to do is drill a small hole all the way through, and then I'll open the top up to the size of the hole. So first I have to square this, make sure it's square, and that's in relation to this here is square because we did all that before when we soldered it together, made sure everything was square. And I'm just double checking, and I'm going to put a shim under here and a hole down there so that it can't move. It's pretty solid now, but I like to be a little more cautious. That should hold it pretty steady. We're centered. So I'm going to put the boring bar in. I'm going to bore all the way through with the proper size for the other hole. And I can do that by measuring this hole. And then I'll open this one up to the dimension. Drill the hole out to the largest drill that I have, and then I'll bore from there. I think the largest drill I have is 1 inch, so I'll have to bore it out quite a bit. So that's 3/4, and the bottom hole has to be 7/8, so I'll have to bore it from here. Back.
I like that.
So we got to go to 875, so we got about 100 thousandths to go. That's we're going to take about 15 of this. See what it does. Thousandths out of there. So we've got to go 875. We got to go 75 thousandths. So I'm just going to take another 15, which is 30. Yep, it's taken exactly 30. So we're going to go one more of 15 and then one of 5. After I bore through the top, what I do is I've set this to 0, so I know just before I hit that other side, I'm at 0. So I'm going to crank this down by hand, down to 0. Okay, and then I can turn the machine back on and finish boring. Okay. We are presently at about 860, and the finished size is 875. The finished size isn't all that important because you're going to make a piece that fits in there. So 5 or 10 thousandths either way wouldn't really matter. So the important thing is to have it perfectly aligned with this hole. So I'm taking a 6 thousandths cut here, which will be the finished size. And like I say, that it'll be within a couple of thousandths, and that's perfectly all right. You to make the other piece to fit it. So there it is. It's about 1.5 thou undersize, which is fine, and that means that the hole in the bottom is the same size. So now I'm going to open this hole up to its dimension, which is over 1 inch. within 18 thousandths of the final cut, the final size. So I'm going to take off another 9 thousandths, and we'll call it good. And that's it. That's perfect. Right on the money. So the next process, we're going to just face this off, just touch it to make sure it's absolutely parallel or 90 degrees to the bores. And then I'll flip it over and face the other side. Just a very, very light cut. That cleaned up this side, took about 15 thousandths. So we're going to flip it over and clamp it down on this surface and just touch the other side. Make sure it's perfect. The two bore holes are, and the thing is flushed off, so everything should be parallel and 90 degrees through here, and it's true this way also. So the next thing I got to do is make the little piece for the bottom and solder those two pieces on there, and that'll be finished. So, the bottom plug that goes on the crankcase doesn't show, so I'm going to make that out of steel, and it's all going to be painted anyway. And I want a piece that's long enough that I can saw it off without trying to do it with a parting tool. So I'm going to use this piece. Yeah, it's a little bit underside. You got to go a little more. There it is. Now, saw it off, and then I'll face it afterwards. Okay, so that's the cover. Goes on there like that, and I got to put probably 6 bolts in it to hold it down. And what happens here is this is going to protrude a little bit down because of the thickness of this. You haven't got enough room for thread and thickness here. So what I will do is when I make the base, I'll just put a little hole in the base for that to sit down into, and that way I won't even have to put flush bolts. I can put little Allen screws in there. And that'll be the finished product right there. Put a little flux on it. Drop the piece in place. I think it goes this way. The right side up. And then I'm going to drop a little solder on there and then heat it from the bottom. That one looks pretty good already. Not to add any more to it. I brushed this so I can see that the solder has gone all the way across on both sides, and I can see it there. Looks good. Should be a good joint. The last thing we're going to do is drill the holes in this and tap them. That's not too interesting. You all know how to do it, but I'll just show you how I started off. I'm not going to use the digital readout this time. I'm just going to use this simple jig that I made up years ago. It's much faster. So I'm going to put that on the edge, and then I'm going to crank it in half the distance of this. It's about a 1/4 inch, so I'm going to go in 1/8. So go 25 and 1. That's right there. So that's 1/8. Everything's tight. There's the first one at 0. And we're going to 6 holes, so we're going to go 60 degrees. So I'm going to drill through there with the 39 drill. Just going to match mark this before I do anything, so I know how it goes on, because those holes won't be in precision and you have to put them in the right place. So there's the match mark, and I'm just going to transfer 1 bolt hole and tap it, put the bolt in, then do all the rest. So I'm going to use the clearance drill to mark it, and I'll take this out and drill through with the tap drill. I've tapped the first hole and I put an Allen screw in there to hold it in place. And now what I'm going to do is mark all the rest of the holes. The match mark is lined up, so I always know where it goes back to. You just touch these. And that's it. I'll take that off, drill them and tap them. Bore you with that. But that's basically the finish of this crankcase. And the next parts I will be making is the 2 end caps, and that'll be another video, and the cylinder. And this will be the end of this video. And if you like the video, give me a thumbs up and subscribe to my channel. That's what helps us. I thank you very much for watching.